All right, this is the lesson for Thursday, January 13th, 2022. So you just start out with an opening moves. You would take 3 minutes. Now, the question that I would have asked today is what is impulse? And the answer is impulse is change in momentum. That is the definition. So just like in every class, just I ask students to take their headphones out, put their phones away, and students have been really good about this, and that just pushes me to make sure that my content is very entertaining, and that way that way we can all learn from what I'm teaching. So then we're still in a pandemic, so we just make sure to remind everyone to wear a mask. All right. So for today, we're gonna explore impulse a little bit more. The agenda: we're just gonna review momentum. We're gonna review impulse. Go over a few more examples of impulse. So there are some assignments this week. So there's that homework due today at 3:20. The rocket sled challenge, that part of the lab is due Friday, so that'd be tomorrow at 3:20. And the bungee lab is due Friday at 3:20 as well. The assignments from last week. So there's that homework assignment from last week, the Arecibo challenge part one and part two. You might not be able to do part one. That's why I'll extend it to next week as well. So don't worry about someone getting that little sheet of paper in. But make sure you get the Arecibo challenge too, and get ready to have a notebook check, or have a notebook when we come in, because you will need to have those notes for next week's notebook check. And also, one thing that you can do at home. So these are all things that you can do at home over this weekend, today and tomorrow. Also, that quiz from last week. If you were not here on Friday, get that in. That's just a fun quiz. It's a very easy way to get your grade up if you have not been there, or if you were not here on Friday. Make sure you get that quiz in. All right, so the big question for today is, why do cars have airbags? All right, so let's just review what momentum is. So when something is moving, it has a tendency to keep moving. Objects in motion remain in motion in a straight line. That's what Newton's third law tells us. So this property of body to keep moving has a special name. It is called momentum. So momentum depends on not just the mass, but how fast that mass is moving. So it is defined as the product of mass times velocity, and it is a vector quantity, which means it does have a direction. So we use let's see here. So the unit for momentum is kilogram meters per second. So then we also talked about change in momentum. So how do we get momentum? How do we lose momentum? How do we change our momentum? So in order to produce a change in velocity, you have to provide a net force. That's Newton's first law. Now, to produce a change in motion, we apply what's called an impulse. Impulse is change in momentum. And all you have to do to find the impulse, it's the force times the time interval that that force is applied. So we know that that triangle, that delta, means change in. But impulse is also change in momentum. So the change in momentum is the mass times the change in velocity. So you speed up, you slow down, your momentum is going to increase and decrease. So if we put it all together, it's going to be these equations over on the right. So these are all the same equations, right? So change in momentum equals mass times change in velocity. Well, change in momentum is impulse. And impulse is force times the time interval that that force is applied. And then you can see at that bottom equation, the one that we are going to be using, I expanded the velocity out. So the change in velocity is the final velocity minus the initial velocity. So there are some components to impulse that we need to know. So impulses always occurs in pairs. Impulse pairs always are equal in magnitude. Impulse pairs are always oppositely directed. Impulse pairs always occur simultaneously. Impulse pairs never cancel because they act on two different bodies. So these should look very similar to the components of Newton's laws, those force pairs. So let's take a look at what this means, that impulse problem. So let's take a look at a person throwing a ball in a boat. So Newton's third law tells us that there is a force acting on the ball and a force acting on that person in the boat. So which object, the ball or the boat, if either exerts a larger force in magnitude to the other object? Well, they're going to be equal, opposite and equal forces. So which object applied the force first? Well, they're going to occur simultaneously. So they start at the same time. Well, which object applied that force for a longer period of time? Simultaneous. So it starts at the same time, it ends at the same time, it's applied for the same amount of time. Now, if they are equal and opposite, applied for the same time, start at the same time, end at the same time, why don't they cancel out? Well, because they act on two different bodies. One of them, he's pushing that ball, and the ball's pushing back on him and the boat. Now, which object, the ball or the boat, if either, experiences a larger impulse? So we already determined that the forces on both are the same, and the time that the force is applied is the same. Well, impulse is force times the time interval. So the impulse experience is going to be the same. Which object experiences a larger change in momentum? Well, impulse is change in momentum. So it's going to be the same change in momentum. Now, why is the effect of the same impulse different on the objects? Now, so what I wanted you to see here is that the force applied to the ball and the person throwing the boat, it's the same. It's applied for the same amount of time. However, well, we also have change in momentum. So I have mass and velocity. So notice that person in the boat has such a large mass, and the change in velocity is not going to be that much. So the same impulse isn't going to have as a large effect. And you can see that, well, that boat moves back, but not as fast. Now you can look at the ball. Notice that it has a smaller mass relatively, and it's going to have a larger change of velocity. Notice it moves pretty quickly. So now let's see how else we can look. We can look at impulse, the force, and that time interval. So this video shows an egg hitting a wall and hitting a bed sheet. So think about which scenario the object experiences greater impulse. So let's look at an egg being thrown at the wall and an egg being thrown at the egg sheet. So you can watch that video, and I've posted a link. You can also play it on the slide. In which of these scenarios, the wall or the sheet, if either, does the egg experience a larger change in velocity? Well, what's the end result? The end result is that they come to rest. Well, in which scenario, the wall or the sheet, if either, does the egg experience a larger change in momentum? Well, if it's the same egg and they're going the same velocity and they come to rest, it's going to be the same change in momentum. In which scenario does that egg experience a larger impulse? Well, it's going to be the same impulse because impulse is change in momentum because they both come to rest. Now, which scenario does that egg take longer time to come to rest? Well, it's going to be the bed sheet. That bed sheet is going to slow it down, or it's gonna stop it, but it's gonna do it over a longer period of time. So in which scenario does the egg experience a larger force? It's gonna be the wall. That's why it cracks. So which variable does hitting that bed sheet increase? It's gonna increase the time interval that force is applied. And which variable does hitting the bed sheet decrease? It's going to decrease the force that's applied over that time. So if you look at this, well, the mass is the same because it's going to be, we'll just say it's the same egg. The change of velocity is going to be the same because it's coming to rest. Well, notice that when it's hitting the wall, well, it takes a very short time to come to rest, so it's going to experience a very large force. Now notice the force. Now notice when it's hitting the bed sheet, well, it's going to take a longer time to come to rest. So it's applying that force over a longer period of time, so that force experience is going to be low. So let's take a look at this and ask, why do cars have airbags? So this video shows how much an airbag helped during a car crash. So think about how airbags affect those two variables, the force applied and the time interval that force is applied. So if we look at that, in which of these scenarios, right, this crash test dummy hitting airbag and the crash test dummy hitting the steering wheel, right? Which of them experiences a larger change in velocity? It's going to be the same. Either way, they're going, if it's driving the same speed and they come, it's going to stop, right? That person comes to rest. In which of these scenarios does that dummy experience a larger change in momentum? Well, assuming it's the same dummy, well, the same mass, it's going to be the same change of velocity, same change in momentum. Which of these scenarios does the dummy experience a larger impulse? Well, the change in momentum is the same, so that means the impulse is the same. Those are the same question. In which scenario does that dummy take a longer time to come to rest? So it's going to be that airbag. That airbag takes a longer time for that dummy, or to slow that dummy down. In which scenario does the dummy experience a larger force? Well, it's going to be hitting that steering wheel. That's why hitting the steering wheel causes injuries, but hitting the airbag, it's a lot safer. So which variable does the airbag increase? It's going to increase the time that force is applied. Which variable does that airbag decrease? It's going to decrease the average force that's applied over that time. So if we look at this, well, the change in momentum is going to be the same, right? Same person, same change in velocity. It's going to be, the end result's the same. They come to rest, right? But the force applied, you're gonna the when you hit the steering wheel, that force that is going to be experienced is going to be a lot larger because it takes a shorter time to come to rest as opposed to the airbag. What it does is it spreads that force out over a longer period of time. So here are the links for the day. Here are the links for some videos. There are other examples that I've included in the slide that might help you out on the homework if you wanted to. Those are just a couple examples that I wanted to go over. And you can see here all the videos for the labs, and any demos are there as well. And there are resources from physics classroom, right, over momentum, impulse, and all of the stuff that I've covered over this week. So just want to let you know that what you can work on, like, just make sure you get the homework from this week done, the homework from last week done, the Arecibo challenge, if you haven't gotten that done, the quiz from last week, that's going to be open. Make sure you get that done. And make sure you have a notebook when you come in Monday. So there is plenty of stuff to be working on during this time. And just as a final thought, remember there is too much unknown in the universe to take a break from learning. Get out there and question everything.